Okay, welcome to another video. This is going to be part 13 of the Wild Networking series where I read the LAN and wireless LAN solution design guide from Cisco. I've only got about 10-15 minutes here, so I'm going to keep this right on track. This is the Cisco Catalyst 9800 series configuration model. The Cisco Catalyst 9800 series wireless controller configuration data model is based on design principles of reusability, simplified provisioning, enhanced flexibility, and modularization to help manage networks as they scale up and simplify the management of dynamically changing business and IT requirements. The configuration model maps IPs to three types of tags, policy tags, or maps APs, access points, um, for wireless uh, uh, like signals. They originate at these access points, and they have three different kinds of tags. The APs, they're policy tags, site tags, and RF tags, which I believe stands for radio frequency. Okay, so let's take a look at the model. We've got our access points and we've got our tags. We have a policy tag here, which can be used for WLAN profile, policy profile. We've got our site tag, which will be for a AP profile or a flex profile. And then we have a RF tag. And here we have hertz because RF is for radio frequencies, so frequencies are measured in hertz. So we've got an RF profile at 2.4 hertz, and we've got a RF profile at 5 hertz. Wireless clients and APs derive their configurations from the profiles contained within the tags. The properties of a tag are defined by the policies defined within profiles associated with the tag. Profiles represent a set of attributes that are applied to the wireless clients associated to the APs or to the APs themselves. Profiles are reusable entities that can be used across tags. Policy tags. Policy tags define the broadcast domain list of WLANs to be broadcast within the policies of the respective SSIDs. For ease of deployment, tags can be assigned based on location and filter, as opposed to statically assigning tags. Policy tags are associated with a WLAN profile and a policy profile, each with their respective attributes shown in the figure below. Okay, so let's take a look at some of these attributes for the policy tag. So the components of the WLAN profile, and we've got components of the policy profile. WLAN profile, wireless local area network, has the status, profile name, WLAN ID, and etc. Policy profile, okay, status, local switching, etc. I was kind of hoping it would be clear kind of what the difference between these two were, but I mean, status shows up twice, so I guess I don't see any clear difference between a WLAN profile and a policy profile. I guess a policy would have QoS. Yeah, I see QoS there. And there wouldn't be any QoS in the WLAN. The WLAN, you probably have like VLANs. Um, I guess I don't see any VLANs, but uh, yeah, I don't see VLANs anywhere on here. Oh, well, that's interesting. You got VLANs under the policy. Okay, so yeah, I guess I'm not sure what the difference is between those two, but here's some examples of components that fall into those categories. Profiles may include additional components not listed in the figure above, and this is not an all-inclusive example. There are additional things that can be added to either of these, and it kind of makes me wonder, are there things that overlap and could be added to both? This is actually not a accurate diagram. It should be more like a Venn diagram because we can see status belongs to both of these. So these should be overlapping according to what we have here. Site tags. Site tags define the properties of the central and remote sites. They also define the roaming domain for Cisco FlexConnect APs in a Cisco FlexConnect deployment. Site tags are associated with an AP join profile and a flex profile, each with their respective attributes shown in the figure below. Okay, so here's the AP join profile defaults. We got default in terms of time, in terms of whether it's enabled or not, and then a flex profile. Looks like you modify these defaults with it, or actually, I'm not seeing. Yeah, I'm not seeing overlap between these two. So yeah, I guess I'm not sure why they're kind of calling out these. I guess it's a data model, so yeah, I'm not sure why it's modeled that way. But let's just keep on going. The goal is to just read this whole thing, just for just for the why do you run a marathon? Why do you run a 5K? You do it not because you want to be able to walk across the street or walk to the grocery store. You do it to increase your um, overall fitness. So that's what we're doing this for. So let's continue. RF tags. RF tags define the properties of the group of APs. RF tags are associated with a 2.4 gigahertz RF profile and a 5 gigahertz RF profile with their respective attributes shown in the figure below. And I believe this is gigahertz. Gigahertz? Yeah, gigahertz. Okay, so here's some components. Profiles may include additional components not listed in the figure above. Cisco Catalyst 9800 series wireless controller configuration can be managed using Cisco DNA Center, netconf/yang, Cisco Prime infrastructure, and web-based graphical user interface (GUI) or command line interface (CLI). Cisco Catalyst 9100 series APs. Cisco Catalyst 9100 series APs can handle the challenges of the next generation network, going beyond the Wi-Fi 6 802.11ax standard. Cisco Catalyst 9100 series APs are resilient and intelligent and provide integrated security for mobile clients and IoT devices. Key benefits of the Cisco Catalyst 9100 series APs include the following. Wi-Fi 6 and beyond. Wi-Fi 6 reduces latency and increases capacity for demanding applications on more devices. Cisco improves on it with programmable RF ASICs. And ASICs are a form of chip. I'm not sure what it stands for, but it's hardware. It's like special hardware, um, kind of like a CPU, but it's like an optimized CPU. We advance more wireless efficiency with intelligent capture, which provides Cisco DNA Center with deep analysis. And I'm not sure what Cisco DNA. I think it's like, let's see what it is. So Cisco DNA, digital network architecture. And then we'll just look up what ASIC is. Um, so it's an application-specific integrated circuit. Addresses IoT expansion. The Cisco Catalyst 9100 series offers multilingual support and application hosting of IoT protocols. In addition, IoT devices, as well as user devices, can see up to 3 times less energy consumption and more stringent security. investment protection with multi-gigabit. The Cisco Catalyst 9100 series supports NBASE-T and IEEE 802.3BZ Ethernet compatibility to seamlessly offload network traffic without bottlenecks. With Cisco Catalyst switches and Cisco multi-gigabit technology, you can use your Category 5E or 6 cables to achieve speeds up to 10 gigabits per second. Available with embedded control, you can choose an option that is easy to deploy and manage and doesn't require a physical appliance. Cisco Catalyst 9800 Embedded Wireless Controller (EWC) can be built right into the access point. The following table summarizes the APs discussed within this guide. Okay, so here's different kinds of access points you can choose. We'll skim this. It looks like it's ordered from small to large. So, oops, but it looks like it's a little bit out of order because this one almost looks like it's. Oh, okay. So this is mission critical, but you can even go one step above that and get the absolute best that you can that money can buy, and that's this Catalyst device here. So it looks like everything's pretty much the same. I guess a big difference is this you get Cisco Clean Air technology with those two ones. This is probably a big one too. Flexible radio assignment, being able to change have more control over the radio frequencies and stuff. So yeah, that's a big difference when it comes to larger versus smaller networks, is having more control over that. Um, yeah, and then between these two, they're both for small and medium. Looks like there's some differences here. Looks about the same. You only have an internal antenna, no external antenna. So yeah, these are pretty much the same. Radio available for future use. Support for two key technologies differentiates the AP selected for deployment in the campus WAN. 802.11ax Wi-Fi 6, the IEEE 802.11ax Wi-Fi 6 specification provides for significant enhancements to wireless networking performance, including the following: higher capacity, attach more devices than under previous standards through features such as orthogonal frequency, division multi-access OFDMA, and multi-user multiple input, multiple output MU-MIMO. Wi-Fi 6 communicates in parallel with devices, whereas existing standards communicated only one at a time. Improved power efficiency using target wake time (TWT). Client devices that support the Wi-Fi 6 standard may consume less power. This means that batteries in products such as smartphones, laptops, tablets, and IoT devices can last longer, which makes it the ideal standard. Reduced data latency by optimizing packet scheduling, which is ideal for voice, video, and gaming applications. Greater IoT coverage by bringing the benefits of Wi-Fi 6 to 2.4 gigahertz band. Increased speed, gain, and access in average throughput in congested wireless environments. Improved security. WPA3 is certified with Wi-Fi 6 and provides a greater value proposition than WPA2 for enterprise Wi-Fi networks. It offers enhanced security for Wi-Fi networks with encryption of unauthenticated traffic, robust password protection against brute force dictionary attacks, and superior data reliability for sensitive information with 192-bit encryption. Cisco radio frequency application specific integrated circuits. The custom Cisco RF ASIC available within the Cisco Catalyst 9120AX and 9130AX series APs Access points provides enhanced off-channel monitoring, improving serving radio performance by as much as 25%, as well as flexible radio assignment (FRA), clean air wireless intrusion prevention system (WIPS), and DFS detection. This silicon level intelligence creates a self-healing, self-optimized wireless network that mitigates the impact of wireless interference. All right, so that's going to be it for this video. Thanks for watching. Next video will be DNA spaces, which stands for digital network architecture.